Right, let's get started. Thanks everyone for joining this session. I think it's already the sixth webinar that we're doing this year in 2023. This webinar, the content of this webinar will all about data quality on your IoT or sensor data, and it's in partnership with Timeseer.ai that we're doing this presentation. But maybe before we get started, let's go over some practicalities. Voila. So all your questions, all the burning topics can be asked in the Q&A panel or in the Teams chats. When experiencing some issues, we propose that you leave and re-enter the webinar. And of course, the recording will be shared after this webinar session. So I will host the session today. My name is Timothy from Brussels. I'm in the company of four other knowledgeable people, IoT and sensor data, so I will let them present themselves.
Yes. Hello, my name is Jana, so I'm working at element61. I've been in the data field for a couple of years now, but the last 2 years working as a data scientist. So I'm mostly analyzing the data, getting insights of the data, and visualizing these insights as well. I've worked with some clients in the past that are dealing with sensor data, so I know firsthand the issues that can pop up with them. And I've also done, together with Timeseer, a POC with one of our clients, so it was really nice to see that, to experience and to see how it works.
Hello everyone, my name is Louis. I'm a data engineer at element61, and I'm a strong believer in data-driven solutions that will help businesses grow. I'm very fond of using AI, but especially with a focus on being pragmatic and business-oriented. And to achieve these data-driven goals, I love laying solid infrastructure in Azure. And of course, I know the importance of data quality, making data-driven solutions. So I'm very fun to be here today and to work together with Timeseer.
Myself, Wimus, so I lead the sales team for Timeseer in EMEA, and from that perspective, I think we all know that there's a large potential for AI in the industry, but I think one of the main challenges we see is indeed the quality of the sensor data and the IoT data. From that perspective, looking forward to the session. I think from our from how we look at things at Timeseer, it's all about people, process, and technology. So I think the goal of the session is to provide you further insight into that.
All right, to conclude, good morning, everybody. My name is Sebastian Verelst. I'm part of the customer success team and leading the advisory board within Timeseer. I am passionate about digital transformations, which is centered around sensor data, and therefore my interest in data quality, making sure that people rely on high quality sensor data or IoT data, making sure that everyone understands data and empowered that people can use sensor data at scale to drive digital initiatives.
Yes, so I will first situate a bit why we need a tool as Timeseer, and afterwards then Wim and Sebastian will tell you more about how the tool works. So I will go over some pain points that we experience with some of our clients working with sensor data. So the first one is being that bad data quality can have an impact on your data analysis and modeling, of course. So it's really difficult to do some analysis sometimes to make a profile of a sensor if you have to deal with a lot of data quality issues that are happening at the source. Sometimes it's also difficult to identify these issues. Is it normal behavior or is it an anomaly? And of course, some issues we don't detect easily, and then they end up in our end results of the analysis of our model, which makes them less accurate, of course. Another issue that we see a lot is that it's difficult to detect data quality issues. So what happens most of the time is we end up making a report or an analysis or a base table, and we see for example, something going wrong there. There are null values that we don't expect. And then we have to go back through all the pipeline, through all the transformations that we've done in there to search where the issue occurs. And most of the time it's just the source data where an issue happens. So it's a lot of time that we put in there as well. Something else we see a lot at organizations is that there's no real automatic data quality monitoring setup, which of course leaves the risk then that some data quality issues are undetected and they end up, as I said before, at the end of the pipeline. Another point that's important is the data knowledge. So what we see a lot is that either there's not much knowledge around the data, around the quality of the data, or that there some, for example, it could be that there's an engineer at the plant who knows very well the range of values that a certain sensor can take, but this information is not stored in a central way. So I, as a data analyst, cannot have no possibility to access it. And so I don't know, and I include those values that are not valid in my analysis, which of course has impact on the end results. So it's important that some knowledge of the data is shared and centralized, and also context of the data. We see a lot that sometimes it's normal that a sensor behaves this way because this happened, or the plant was closed, or that happened. But if that context is not available across the organization, each data analyst loses time in searching why something happened while it could be easily explained. And then the last pain point that we see a lot of at organizations is that there's no clear aligned approach on data quality. So what could happen is we detect a certain issue when we're working on a use case, we fix it, we clean up the data for that use case, but then maybe there are other people of other use cases that are using the same data, and they haven't experienced that issue yet, so there it's not cleaned up. So there's a misalignment in approaches on data quality. So it's important that that an organization has a clear strategy on how to clean data and how to approach data quality. So for an organization, it's important to address all these pain points that I've listed up now, and a tool like Timeseer could help with that. But Louis can explain more about the added value of that.
All right, so now let's look at the same modern data platform with Timeseer ingested in it. With Timeseer, it's very easy to detect IoT and sensor issues, and we can clean them up front. And this can happen between every layer of our medallion architecture. It probably makes the most sense, or is most important, to do this at the source in the bronze layer, because that way you have clean data before any downstream transformations, assuring data quality throughout your entire data pipelines. Of course, our modern data platform supports streaming use cases, and Timeseer also supports real-time data monitoring. So this is no blocker to work with qualitative data even in real time. Metadata and other context about Timeseer's data, such as the profiles, etc., are centralized, and they can be shared and used throughout the platform, addressing the issue of the data knowledge that's being isolated now by certain people with niche experience. And Timeseer does not form a bottleneck in this entire data platform, because it allows for defining transparent cleaning strategies that are triggered and run automatically, the same as your data pipelines run automatically, and it fits seamlessly with all technologies. And to define these cleaning strategies, it offers more than 100 data quality checks and KPIs, and also the possibility to customize these so that you have really tailor-made data quality throughout your entire platform.
From a Timeseer perspective, the why Timeseer, the reason why we started Timeseer about 3 years ago is that we basically saw a niche in the market and a problem that needed addressing. As I said during the introduction, we all know that the potential of AI for the industry is huge. But what we noticed the past year is that there's been a lot of focus on the left side, what you see there on the left side of the wing of the airplane on the modeling. But in order to do good modeling, you need to have good data. And that's also what you see on the right-hand side, the top challenges in facing analytics initiatives today. Basically, the elements that are blocking a successful digital transformation, data quality issues is one of them. From a Timeseer perspective, we aim to be the experts when it comes to sensor data and how we try to fit into the ecosystem and into the data pipeline, as Louis and Jana explained. So from our perspective, we don't need better models, we need better data to get to better models. Now, why is time series completely different type of data? I think traditionally, when we look at relational data, what you see right now, you see basically a number of the arrows. You see that firsthand. You see an A somewhere in a phone number. Is it with a dash? Is it with a plus, and so on? You see the differences there. You also see the difference on names, for instance. That is typically elements in which that you see where relational data is looking at. By the way, the phone numbers are real, so if you want to give Adriaan or Sebastiaan call, go ahead. But wait till after the session, please. So this is what you see with relational data. Sensor data is a completely different type of data to manage. If we look at things, typically the data comes in like that. I think first of all, what is quite important is the context about the data. I think that's element number one. It's also important to understand the way that the installation, the machine, the devices are being operated. So you get, is it the temperature we're talking about? Timestamps are different. Is it part of a larger installation? What type of asset is it that we're looking at? What is the product we are producing at the moment of that? And then you start looking as well into the issues you see with data. For instance, there you see clearly, you see a data gap. But is that partly, could that just be that data gap? On other elements, you see drifting. Is that drifting just over a short period of time? Is it drifting over a longer period of time? How is that correlated to other outliers? So sensor data really requires a specific type of expertise and of knowledge. And that is what over the past years we have been building within the Timeseer platform to ensure that all that knowledge is available when looking at that data. How to position actually Timeseer from that from this view? So first of all, I think there are a number of key elements. What you see here on the slide. So first of all, today, if we look at it, how are we solving sensor data today? We see sensor data issues are being carried along through the data pipeline. Typically, decisions are made in a reactive way. And it's unclear where the impact is made. So traditionally, what we see at companies is that sensor data quality is solved on what you see on the right-hand side of the slide during data science projects, dashboarding, digital twin, trending. That is basically where we see that today's sensor data is being solved. From a Timeseer standpoint, we have a different view on things. That means that what you see on the left-hand side of the slide, two elements that we do. First of all, what we call data observability. That is, we provide you an insight into your sensor data. That basically means do you have an issue with the device, with the sensor, or do you have an issue with the data coming from the sensor? Where do we do that? Well, typically, I think Louis explained that with, for instance, an medallion architecture. We also do that on a historian level, on an IoT data lake level. It depends. There are multiple places along the way where you can intervene. First of all, so as I said, data observability as step one. And of course, the moment you know where you have a data quality issue, we also provide the capabilities to correct them in the stream and at scale.
Yeah, that's indeed what we see during customer project, that a lot of sensor data quality issues are appearing in downstream applications. But let's pause here for a moment because we first want to understand if you have faced some data quality issues during your activities when you built an AI model or when you take a decision based on a specific report or dashboard. So do you face some data quality issues from sensor data, IoT data? So please provide your votes. And then next question, if you have a tool in place or if you are aware of sensor data quality issues, how do you monitor them today? Do you have a specific automated solution in place to monitor during the data pipeline if there are some data quality issues, or do you just do some manual investigation, start from scratch, have some specific procedures in place to monitor data quality and to correct data quality incidents? All right, we see some very interesting results that a lot of you also are facing with some data quality issues. That's exactly what we also see during customer projects when people are building digital twins or reports that sometimes no data is coming in, such that no decisions can be made. When people are aggregating data from seconds basis to 1 minute basis or 1 hour basis, that we also have a lot of lots of information, which also has impact on reporting. Within the chemical industry, we have done some projects where we have detected that a specific pressure transmitter was blocked. This has led to a plant shutdown of 120,000 euros per year. So by having Timeseer and running Timeseer continuously, you can detect with one of our checks if a specific asset is failing. And within the data science space, you also see during the demo that I will give that we can speed up providing insights in data quality issues, also correct them on the Timeseer platform as such that you can speed up your analytics use cases with up to 50%. So more about the Timeseer technology, as we also indicated, we fit within the landscape where we are an official partner of Microsoft. We have a lot of experience with different type of data sources, data lakes. We can connect easily to the most common historians like an Ozisov Pi, AspenTech, Yokogawa, the data lakes. So we can easily connect to both data as well to metadata, because metadata is very important to understand data, to also see if the settings are correct. You can interact differently with Timeseer within the middle layer. We have a web application that will also be what I will show during the demo, how to log on our web application. But everything that we do on web application can also do via our Python SDK or via some specific REST APIs, also via specific YAML or TOML. You can also configure your resources and get your insights. So your data quality scores, your event frames. Event frames are periods of data quality downtimes. You can also expose your cleaned, verified data set in downstream applications. So we also have some APIs which you can also find on our Timeseer platform, how to expose all these insights to visualization tools, to data science platforms, or within data catalogs, where we can easily integrate our data quality scores within the most common data catalogs. If you have any questions about architecture, about capabilities, you can always put them in the chat. Now, what do we offer? Our Timeseer platform, we have 4 building blocks. For the moment that we are connected to a specific data source, or if you have an offline file, a Parquet file, a Feather file, a CSV file, you can upload offline files as well. We are going to profile first your sensor data to understand what type of data is within the source. Are we talking about temperatures or pressures, speed measurements, vibrations, and so on? From the moment that we have profiled your sensor or IoT data, we're going to run our data quality checks on your data. You also see on our platform that we have 100 data quality checks in layered approach. We have a fundamental approach. We're going to check for the basics, but then we also have some out-of-the-box best practice KPI sets for control loops, KPI sets for data science purposes, KPI sets for ESG reporting sustainability. If we found some data quality incidents, You can also clean data quality within our data refinery block. And for the moment you want to expose your data to downstream applications, downstream users, we provide some data certificates, data labels to your data, such that everyone knows what is the data quality of my data on which I'm taking some decisions. What you will see during the demo is to better understand what type of data quality checks do we offer on our platform. We are a startup. Every 2 weeks we have a new release. Our R&D team is continuously developing new checks, but we're also a strong believer of extending our platform. So if you have some specific data quality checks, you can also upload them easily on the Timeseer platform and it will remain your IP. We offer a data quality heat map where you can see easily with traffic lights where are the data quality issues, the critical issues in red, the less critical issues in yellow, and as said, everything is visible in a low-code or no-code UI. If you have some data quality incidents, you can easily impute or correct data quality incidents. Also here, we can extend our capabilities as such that you can upload your own specific augmentation strategy. We also have our AI imputation strategy, where we're going to learn from the trend of sensor data to impute by taking into account what is the trend of my sensor data. And then the last part, protect. For the moment, if you're going to schedule a specific flow on a Timeseer platform, and you want to get a notification if a data quality instance is appearing, we have some notification handlers via Teams, Power BI APIs, via mail, so you can get informed about the data quality incidents. Enough said, enough slides. Let's jump into our demo, where I will show you what type of data quality shows, data quality KPIs do we show on the platform, how to find a critical issue, and also how to correct them on the Timeseer platform. For that, as Jana and Louis indicated, we've done some use cases together. We will start from one of the customer use case that we've worked on together on some raw data of 4 months data, where we will show you how we profile data, what type of statistics do we calculate, how to run the data quality checks, how to add a specific data quality check, and how to make sure that we can clean it as well on the Timeseer platform. So if we log on the Timeseer platform, what you'll see on the main screen is a specific dashboard of your specific project that you can easily filter on some additional projects. But now we focused on one specific use case. We can easily see that we have analyzed 23 time series, of which all of them are in a critical stage. If you want to have some more information, you can easily click on the series results, where you navigate to the specific heat map, where you can see that we have analyzed 4 months of history, where we see over time for the specific series where are the critical issues located, what are the smell or the bugs or the warnings that we have on the Timeseer platform. Now you probably wonder what type of data quality checks do you run in this project. You can click on the KPI sets, which we've customized for this project. So if you click on it, you will get some more information about what type of data quality checks do we run in the specific domains. First of all, we're looking to a completeness point of view. Is data available? NANS, if you're not familiar with the concept of NANS, you can click on the help button where you get an explanation. What is a NAN? And we expect from sensor data that we have a numerical value. A NAN is not a number value. You also see how it's calculated, how it ends up in data quality score. From an integrity point of view, we want to avoid duplicate records. We want to have sorted data. Certain historians, they provide a bad quality flag at the source level. We can also take that information within the Timeseer platform. We expect from time series data that it's updated regularly. So if you click on the help page, you see that in this case, every 5 minutes, we see a new timestamp, but here we see some increased gaps of 10 minutes. Another quite important one, which you see across our customers, is stale data or frozen data. We see also the slide of Wim. We expect from sensor data some variation. What you will see here in the middle is that data has been frozen for 5 data records. So that's also something fishy. And then you can also run the more advanced data quality checks like drifting, IQR anomalies, oscillation, and so on. You can customize your KPI set. You can easily add a new KPI set to your KPI set. If you want some more information about the entire offering of the Timeseer platform, you can go to the help page, go to score documentation, and here you will see the entire list of all possible data quality checks that we are offering right now. For example, let me zoom in the redundant sensor drift. Some sensor data can be correlated, but you want to be notified if 2 correlated sensors are deviating over time. It is also one of the checks that we monitor. I also refer to control loops. We also have some control loop checks on our platform, specifically within the manufacturing industry, where you have a set point and you expect that your real value is in line with your set point. So this is also something that we can monitor on the Timeseer platform. So if you want some more information about the specific KPIs, you can reach out, or you can just put it in the chat. So if you go back to this view, you can see that we have some data quality incidents. Also below, we have a summary page where you can see how many series are impacted by data gaps, by stale data. You can visualize it in the number of series count, but you can also get the number of scores. What is the percentage of time that we have data quality downtime for the increased archival step size? 3% of the analyzed data is fishy. You can also get, and my screen is frozen now, count of event frames. We will see, look, I have 19 periods of stale data. So this is also something how to play with the Timeseer platform. Let's dive into one of the issues. For example, you can just click in the heat map on a specific issue here. In red, you will see in this time period, I have an increased archival step size. You can click on it. You can see, look, this event frame lasted 12 hours. You can click on the 3 dots to visualize this event frame. Then you will see in gray, blue, the downtime period, where you will see that my last registered point is at 10:20 in the evening till the next day, 10:40 in the morning. Now, how do we identify this data quality issue? You will see on the left side that we have a statistics tab. In the statistics tab, we are going to calculate the statistics, and we see that for this specific series, we see on average a new data point every 5 minutes. Some periods, we only saw a new data point after 1 day. So based on these statistics, we can flag some increased archival step size. We also see how many data points do we analyze, how much information do we lose if we aggregate from 5 seconds level to 12 hours level or 24 hours level is. So for data scientists, if you're building an AI model and you want a model running on a daily level, you will lose 4% of the variability, but also the distribution, the sketches, and so on, everything we calculate out of the box. And based on that, we identify that this is a efficient period. You can also easily zoom out within the heat map, where you can see that you clearly see that this is an issue. You can also add another parameter randomly on the Timeseer platform just to see if this also is an issue. You can add as many series, and you will see that within the same period you have a specific issue. So that was one critical issue where you can also, for example, if you say, look, I want to dive more into the timeliness dimension, you can click on the timeliness dimension, you get a specific heat map for increased archival step size and still data. You will see we have red and yellow. You can adjust these scores as well. So if I go back to the previous screen to the KPI set, you can click on timeliness and you can change the weights yourself. You say, look, for me, still data is also a critical one. You just add it to 2, and this will also appear red in your heat map. So if I zoom back to another event frame, for example, still data, I just click on still data, 16 hours period of downtime, visualize it. Again, you can zoom out. If you zoom out, you see again here that there is a period of still data, 16 hours, a value of 0. You can reach out, as Jana said, to engineers, to operators, to maintenance team to ask, is there something with this sensor? If you got some information, or if you share this event frame to operators, they can provide some context on the Timeseer platform. So you can edit context. You can say, look, there was a maintenance activity. I reviewed it as such that everyone within the organization is aware of this data quality incident. You can also say, look, this period is not relevant to take into to include in the training data set for data science purposes. So you can also say, look, instead of reviewed, you can also suppress this event frame that it disappeared from the heat map, that everyone knows that I have to remove them from the training data set. Let's jump to another dimension, for example, oscillation, the same approach. You click on visualization. Again, you zoom out. You see here that you have periods where you started oscillating your data. Again, same approach. You can provide this event frame to engineers to ask input to see if this, what to do with this time period. Now, if you want to clean data quality incidents, you can clean them as well on the Timeseer platform. So you go to the configuration of your data quality flow. So here you will see the flow which we have set up for this use case. We fixed first the timestamp duplicates, make sure that every data is sorted. Then we run our data quality checks, where you see we are going to run the statistics, the univariate. You can also run some multivariate statistics. But within the same flow, you can also add a filter or a cleaning step. So if you go to edit, you click on the filter block. Here you can add your specific filter steps to make sure that data quality incidents are resolved. You can do it in the interactive mode. I think I opened the screen here. So here I already added a specific cleaning step for IQR anomalies, for specific Siri, I want to do some linear interpolation. You can also use Timeseer smart imputation strategy based on AI. You can impute with a mean specific value, old last value, but also you can extend this with your own augmentation strategy. You can zoom in on a specific period where you can see the original signal, then the augmented signal to make sure that your data has been imputed correctly, because you see here a value around 54, it jumps to 0. If you look to your augmented signal alone, you'll see that everything is around this 54. So based on this, you can add easily some other data quality event frames. You can apply it on all series or a specific series. Now, if you are satisfied with your cleaned data set, you can add a last block. You can export the cleaned data set, or as said, you can also expose your results via the arrow flight, and then you can pick up the verified data set on the Timeseer. I run through the Timeseer engine. You can integrate it within your Python pipeline, for example, to make sure that when you start with your data science initiative, that you are using a verified data set. So if you go back to the slides, what I've shown is that you can run data quality fundamentals, the really basic stuff. Is data available? Is the metadata available? We also have the more sensor-specific data quality checks. For example, a temperature cannot drop within 1 second from 100 degrees to 0 degrees. We also have some use case specific KPI sets for data science, 25 checks that you run out of the box to help data science within their analytics initiatives. We've also shown that on a Timeseer platform that you can clean your data from raw to augmented data. We can also provide you insight how much information will you lose when you aggregate from 5 seconds to 1 hour data. We also do some audit trails on Timeseer if we're connected to historians and during shutdowns, maintenance activities, if there's a change in the pipeline settings that someone accidentally changed the name or a setting of a sensor, that you get a notification, look, this value, this metadata has been changed. And when you run Timeseer operationally, you get a notification, look, something is wrong, which action should I take? And that's also maybe something that I can show live on the Timeseer platform within the flow. If you click on properties, you can schedule your flow that you can say, look, I want to run this analysis every minute, every hour, every day, every week, every month to get continuous insights of data quality incidents. With that being said, the intention was to show you how we can help speed up data science initiatives. Also on the project that we've done with element61, we've calculated that we can improve the data sets with 60% improved data quality, which we have saved data scientists with 30% during the AI modeling phase. And you have specific steps to take, defining a problem, connecting to a data source, run some data quality checks, integrate with other data sources. And you can also connect to LIMS data, for example, maintenance files that we can also provide context to a specific event frame. For example, for stale data that we can learn from maintenance files. Look, the was just shut down, suppress these event frames. Based on our augmentation strategies, we can also speed up this process. So based on a case that we've done together at Agristo, we've saved 30% of the time of data science instead of preparing the data to focus more on building a reliable AI model. Last slide, we have a layered approach. We always refer within Timeseer to our onion model. We always start with the data quality fundamentals, the basics. It doesn't matter if you have temperature measurements, if you have flow measurements, speed measurements, the fundamentals must always score 100%, and then you can grow in maturity. And if you found some incidents in the data augmentation layer, you can go from raw data to fit for purpose cleaned data. So that was my talk to show you what are we offering with Timeseer, how are we helping data science to speed up, to make sure that they are building data sets verified for that application. And we have a specific approach that we have together with element61.
Yeah, so typically the first step that we take is what we call an assessment. I think the idea behind it is you don't know what you don't know. Is to provide you an insight both on the one hand qualitatively, an insight in what are the typical use cases that sensor data apply to within your business context. Secondly, quantitative, of course, is we take a subset of your data and on which that we run Timeseer and we evaluate what the data quality is. Typically, we do that within a period of 2 to 4 weeks, depending also on availability on your side. Second, of course, is a pilot, more longer-term operational pilot. That basically means that Timeseer is installed within your environment and can be used operationally to run a number of the use cases that have an impact. A goal there indeed is to ensure that the data quality, the sensor data quality, is increasing and impacting the use cases that you have in mind. And of course, one of the elements is a scaled rollout. I think that's also the way that we, together with element61, that we are collaborating and that we are trying to indicate towards our customers what the potential is of having your sensor data quality cleaned up at the source and how it impacts the use cases. We also have a next poll lined up for you, so feel free to go through the poll. I think first one is indeed next step is that would that make sense for you to have more insight into what sensor data quality could mean from your side? Could be more into the use cases, could be a more deep dive demo, a number of elements there that we can address. I think there as well, I think key elements there is that we want to make it as short and as fast as possible. I think those are one of the key elements that we want to take there with you. And interesting to see indeed that it also links back to the earlier polls that we saw. The next question I think we have in there.
That was the final.
Is that the final question?
Question.
Perhaps just opening up the call to the people, if there are any things that you saw, that you noticed, questions you have, burning questions. We have Jana, Louis, and Sebastien here to tackle these questions. So feel free to put them in the chat.
Maybe in the meantime, Jana and Louis can maybe share, because we do this approach at specific customers. Maybe they can already share how they approached the project at specific customers within the 2 weeks vulnerability assessment.
Yeah. And one of our customers, indeed, we've done vulnerability assessments, and we decided together with the customer on which use case would be best to start on, which is the use case that would have the most impact from good data quality. And then we defined some as sensors that we needed for that use case. And then, we went through the process together with Sebastian to set up the whole, to set up the Timeseer platform, to go through the whole setup of the flows, to clean up the data and to check which data quality issues were there. And I think we can say that we noticed a lot of things that we didn't know before, and a lot of issues that were complex to find out, like, for example, the stale data or the anomalies that were things that we didn't saw before. So it was really useful for us, and we directly saw the added value of the platform in really concrete cases that we didn't know about and the customer didn't know about either. But I don't know, Louis, if you have something to add on that.
I totally agree. I think there was a lot of things exposed also about the data knowledge throughout the company. And with Timeseer, we knew what we didn't know, and we had a central overview, and also were able to involve the right people who could provide the answers and provide the context. And I think this way, with a centralized tool, everyone can contribute and make sure that the data quality arrives where it should be at the actual data-driven decision making, but having input from all over the process.
I think one of the important elements there as well is that the focus that we have together is really purely on the sensor data elements of it, because typically there are already initiatives ongoing on data quality, data governance, but then more related to the traditional data sources. The vision that we have together is really to integrate as much as possible within the existing data frameworks and data governance processes, and ensure that also sensor data is being looked at a more strategic level, and ensured that it's there as a key enabler and an accelerator within the digital transformation.
Yeah, I think if there aren't any other questions, then we can finish this webinar. So yeah, thanks everyone for joining us. And if there are any other questions, then feel free to reach out to us or to the people.
Yep. We will share the slides and material, because we've seen that certain people want to have a follow-up. So we will share that material.
Great, super.
Thanks a lot, everyone.
Thank you very much. Bye-bye.
Thank you, everyone. Bye.